Let's take a look at number 14. This is subtracting rational expressions, but it's kind of the same steps for adding and subtracting. So let's refresh our memory on those. Adding or subtracting rational expressions. Step 1. Factor all your denominators. Step 2. Figure out the LCD and rewrite each fraction with that new denominator. Step 3. No, step 2. Step 3. Add or subtract the top parts, the numerators, and put into a single fraction. Step 4, I'm going to say factor the top, factor the bottom, factor the numerator and denominator. The bottom should already be factored, but just in case. And 5, cancel if possible. So let's look at these steps with this problem. 14. We got 8 over x squared plus 6x plus 5 minus 9 over x plus 1. Factor all your denominators. The x plus 1 we can't do anything with. This is the PST method. And the reason why is because it's x squared x, no x, and there's no number in front of our x squared. Well, this is a pretty simple one, but let me go over here and still show the steps. We take the number at the end, which is a 5, and we're going to create 3 columns. P column, an S column, and a D column. In the P column, we write down all the products give us 5. We got 1 times 5. In the sum column, we add those numbers together. 1 plus 5 is 6. In the difference column, we subtract them. 5 minus 1 is 4. The number we're looking for is the number in our middle term, which is a 6, which is right here, which means we use 1 and 5. Not real hard to see this one. Now, larger number in the P column that we're using, the larger number in the P column, which is a 5, is always going to be the same sign as the middle term, which is positive. If the number you circles in the S column, S for same signs, both positive, both negative. Since this is positive, then this has to be positive. So our first fraction becomes 8 over x plus 1 times x plus 5 minus 9 over x plus 1. That was step 1. Step 2, figure out the LCD and rewrite each fraction with that new denominator. Okay, so we're going to start with our first factor, the x plus 1. And we're looking for the greatest number of x plus 1s in a single denominator. There's 1 here, there's 1 here. So the greatest number of x plus 1s in a single denominator is 1. Then I go to my next factor, the x plus 5. And I'm looking for the greatest number of x plus 5s in a single denominator. There's 1 here, none here. So the greatest number of x plus 5s in a single denominator is 1. So that's our LCD. And we want to rewrite each fraction with that new denominator. Well, first thing you have to look and see what the old one had and what's new. You had an x plus 1. This has an x plus 1. Had an x plus 5. The x plus 5 is still there. There's nothing new in our first fraction, so it doesn't change at all. Our second fraction, we had an x plus 1. That x plus 1 is still there. The new thing down below is the x plus 5, so we have to put it up on top. Whatever you put down below, you have to put up on top. Now, the official rule on that is whatever you multiply by the bottom, you have to multiply by the top. So we got 8 over x plus 1 times x plus 5 minus 9 times x is 9x, 9 times 5 is 45. And x plus 1, x plus 5. Step 3. Add or subtract the top parts and put into a single fraction. Now remember, if you have a negative out in front of your fraction, it's going to flip the sign of all the terms up on top. So when we merge this into a single fraction, we're going to have 8 minus 9x minus 45. So it flips the sign of whatever it was over x plus 1, x plus 5. which gives us negative 9x. 8 minus 45 is negative 37. Yeah. Over x plus 1, x plus 5. Well, step 4 and 5 we don't have to do because we can't factor the top. We can factor out negative 1, but that's it. And obviously it's not going to cancel with anything down below, so that would be our answer. Negative 9x minus 37, which would be C. Now let me go down. Let me actually check that. C. Okay. 14C. And it checks.